anyway. You know, the bigger the group, the more I got to do that.
We gotta watch Dave.
I'm going to share my screen then if you all are ready.
Floor is yours.
Okay. All right. You see my presentation in full screen now?
We do.
Okay. Anyway, thanks for having me. I really, my reason, we sent you the some references, but you know, I'm pretty motivated to do this because it can sometimes happen that whether an inspector is told something distracting by a contractor to serve that project, or maybe they saw one thing go wrong and it's what kind of becomes their issue, or maybe their lack of experience. I wanted to make sure to kind of just get all the major bullets out there to you guys, and then that puts you into a better baseline position, I guess, starting point, and you're welcome to talk to people and refine from there. But I felt like this would get you onto a better first path, because I look to you guys as a not everything having to do with the quality of the outcome, but an important part of it. And so I have a trust level with that, and I feel like I owe you information to help you to do a good job of it. As you all know, we're talking about polyester polymer concrete, which is hopefully something we intend to install on the I-395 project. This is made up of a mix that's a lot, I would call it concrete-like. So it's got sand and stone and polyester resin. There is no cement or water. So it changes some of the things that you're looking for in the details and certainly what's on paper. However, because it's a concrete-like, I'm going to say it a number of times during this presentation, it's okay to trust yourselves. Ask us. We're going to have people on site, at least for the beginning of it. And we're available leading up to the job too. Ask us questions, but it's going to come up pretty often that if something seems wrong to you, there's a good chance that you're right. Because if you know concrete, you already come to this with applicable knowledge. This is a different material with different components, but it doesn't make your knowledge wrong. So anyway, it's okay to trust yourself. So it's a concrete-like matrix, and it starts with a methacrylate primer that we'll talk about more in a little bit. General properties not specified, the first two. The third one is specified, but the first two are there to give you an idea of what you're going to see and feel. It's hard. Okay, this isn't like some goo. It's not some rubbery goo. And it's got much more, I think, balanced properties with that high tensile strength to accommodate bridge motions. So again, for what you expect to see, it's a lower. Yes, sir.
Hello?
Yep.
No, sorry.
Okay.
Never mind.
Let me just answer the phone.
Oh, that's all right. I mean, by the way, I'm going to jump when I hear noise, because feel free to ask questions as we go. I forgot to say that. Don't be bashful. I can't see everything on the screen because I'm looking at mine, but speak up if you have a question. I'm willing to address things as we go along. Part of what it looks like in place, got somebody's hand there for thickness, but you see the material. It kind of does look concrete-like, except for it's not angular aggregates and there's no cement in it. Here's what it looks like finished in a patch. Here's what it looks like being placed on a small scale. Good chance you would only see this, an operation that looks like this, maybe in a small shoulder or an approach that they couldn't get with the paver or something, but not likely you see anything like this. This is what you're going to see. This is the final product. Here it is being installed. You see precast panels on the left and the paved PPC mat on the right. Advantages, and these are kind of the things that I'm looking for on the job to get. It's not necessarily specified to get this, but it's buried in the spec, certainly the bond strength. But it cures fast. So that 2-hour traffic ready cure, what does that tell us from an inspection standpoint? What it tells me is you've got a narrow window of time to see problems. You kind of have to be active here. It's not an operation that you can disappear from and show up later until things are really clicking. There's a point where the job is just going and it gets, kind of boring. It's just repetitive. They're just marching down the road, not different from asphalt or other concretes. But because of that fast cure time, you do have to be paying attention. That integrated chemical bond to the substrate, we're going to need to make sure that some prep and proper primer placement and timing are correct in order to get that. So that's an advantage you get only if things are done right. Constraints, big time what you got to watch for. 40 to 100 surface temperature for overlay placement. We work below 40 often enough. I don't think under 40 is going to be an issue here in Miami. Over 100 might be. If it gets over 100, it's not like it turns to garbage. So usually what I say from an inspection standpoint on the temperature is if they've got an end spot and it's, 100 feet up, and an expansion joint or the end of the pour or something, and it's 100 feet up and it's 98 degrees, don't freak out. Don't stop them. I'd rather not have a stop and start mid-job. Let them keep going. It's okay to go hot. It's on them to make sure to get it finished. But I wouldn't start the pour at 9 a.m. and the surface is 90 degrees. You're going to be over 100 soon. So things to watch for. Thickness, I don't think that's going to be an issue. We're placing it just enough above the minimum that you'll be okay. The other thing, dry conditions. We're going to have people out there at the beginning of the job helping to coach this. Dry means just dry surface. Doesn't mean if it's humid conditions, you're okay. Can't be raining. It just has to be dry. It's not hard to judge, but plan to not place in the rain. On to some finer details. Spec issues. Yes, sir.
Excuse me, I have a question.
Yes, sir.
When you've been grinding, if we have an expected rain, in Miami, all of a sudden it rain for 2 hours and then it stop.
Yep.
If you foresee that rain is coming, should you proceed to lay the material or wait until conditions are perfect?
Yeah, so once the material is placed, we're going to get in much later in the presentation into how to check gel time and what you're looking for. That's the initial set. It's basically when it goes from the resin is in a liquid state and then it sets, the material sets up and begins to develop strength and becomes a solid. After that point, rain all you want. Okay, so if it's going to rain later in the day, place in the morning, absolutely, and then let it get rained on after it sets. So you want to stop 2 hours before the rain, and then not worry about it. That's fine. You don't want to get caught in the rain. So if it's uncertain, I live in Florida. I'm used to coastal weather. Sometimes these cells just blow a little south of you. Sometimes they hit you. You got to be a weatherman. You got to watch the radar. Don't get caught in the rain during placement. Don't get caught in the rain within an hour or two after placement. After that, you're fine. Okay. Let's see. So these are kind of some spec items, not super critical. They're going to give you a placement plan. Check it. Trust yourselves. The reason I didn't give a whole lot of detail with this is because it's kind of self-explanatory. You guys are smart people. You're used to checking placement plans. Just do it. Make sure it makes sense. Make sure everything's been addressed. I'm not going to waste time on those details. In the equipment section, you want to make sure that the mixer trucks are calibrated, and they can give you a calibration certificate from elsewhere, or they can demonstrate it with scales on the job. That's up to your comfort level, and we can help guide that too. TrueStel's used to it. Your installer, they're used to that periodically, so they won't be surprised. And the placement equipment, they're going to come with pavers that are specifically built for our PPC, so you won't have a problem there. Usually the placement equipment comes into play when somebody brings in ordinary concrete equipment like a screed or something, and we check it out a little bit, make sure it's okay. Not going to be your problem.
Pardon me, I got a question. Good morning.
Yes, sir.
Usually for our volumetric mixers, we try to have the calibration immediately prior to actually commencing the project. Mm-hmm. Mm-hmm. Is that customary for these two?
Borderline customary, pretty customary. It's not every single job, because often these guys aren't switching materials and they're not switching applications at all. So they're just going job to job with the equipment. There's no change to the mix design or anything. So if they can demonstrate that it was calibrated on the previous job and demonstrated to a qualified person and they have some kind of a certificate, that's certainly acceptable if they can demonstrate it. If they can't, or if you deem it necessary, they can demonstrate that it's calibrated on site and run off individual components, put them on scales and show that it matches the ticket given. That's kind of, I'm going to defer to your trust level with that. This equipment wasn't built 4 years ago, calibrated then, and it's still working now. It gets recalibrations happen often enough. I believe your standards that you'd be used to for a latex or any volumetric mixing, these guys can fall within those standards.
Thank you very much.
No problem. So the trial overlay, it's in the spec. It's something that you're going to do. In general, because you've got proven material, experienced installer, you don't need to make them figure out how to do this offsite where it's, disposed of. The 99% of the time, trial overlays in this kind of a setting happen on the bridge. 99% of the time, trial overlays happen on the bridge and are bigger than just the minimum 20 feet or whatever the spec says. Usually it's the first shift, and it's can sometimes be a light shift, maybe some joint to joint or a couple spans. Excuse me. But very common to be on the bridge. If something goes wrong with the trial, it's the contractor's risk. It's not like you accept it ahead of time. So it's customary to have it happen on the bridge. I like the trial because it's a chance between us, QuickBond, and you, the inspectors, to ask questions maybe on a lighter production day, and get some of the questions and concerns and information out of the way on that day, so that when they get to production, they can roll. I look at it as a good opportunity for that. And like I say at the bottom, if something doesn't look right, ask. We're there. Truesdale's there. This is your chance to ask. And I feel very strongly that from an inspection standpoint, you all deserve confidence, and it's hard to get with a new item like this. So this is a good chance to help build your confidence and transfer some knowledge and expertise to you guys. Testing, one of the early tests that happens is the tensile bond test. This is a ASTM C1583. It's a relatively standard test. 250 PSI minimum bond strength is industry standard. That's nothing. You guys are working on presumably good quality precast. I can't speak for the strengths of your bridge, but I can say in general, precast gives a lot more tensile strength than that. What we're looking for is failure in the substrate. That's it. The numbers are less important to me. I think we're pretty well assured to get over 250 PSI because it's nice new concrete, precast, cured in perfect conditions. So really we're looking for breaking in the substrate. And you see that picture down on the bottom. The puck is sideways, overlays on the left, substrate concrete's on the right. We're going to see something along those lines. This picture is a good one because it pulled a ton of concrete from the substrate. You may not have that, but that's a function of your concrete, not the overlay.
Can you describe actually for the team here what the bond test is? How do you perform it?
Yep. So first off, you're going to have people do it who do it, whether that's Truesdale performing it because they're used to it or an outside engineering firm. But you take it's a 2-inch core drill. You drill just past the bond line. So basically, you're watching the slurry as it comes out from the core operation. And when you get into the substrate, I believe you go a 1/4 inch into the substrate and stop. You don't want to go too far because then you risk eccentricity. But you drill into the substrate, then they dry it up, clean the surface, and they glue puck to the top that gets attached to a tensile pulling machine that you wait until the puck adheres. Usually it's like the next day. And you pull it, and it gives you the strength. You divide the strength by the area, and that tells you your bond strength. Now, that gives you the number, okay? Again, I'm looking, and it's a straight up pull, and the machines are made for it. They're small, they're accessible, common pieces of equipment. Nothing that I'm describing here is unique to our material. by the way, this test. Happens for shotcrete and other overlays and coating systems and stuff. So you get the number, but what I'm looking for is breaking in the substrate and just making sure that the primer wasn't contaminated and the prep was acceptable, and that the material has cured to its strength. Our overlay is stronger than your substrate. I don't care how good a precast you have. Our overlay is stronger, especially in tension. And so we're expecting to break in the substrate. To me, that's a passing result. Numbers are great.
My concern is the location, where you actually do it because of, what we have out there, this reduced cover and potentially issues.
Yeah,
with
I would love to not see sparks from your PT tendons.
Yeah.
Sure. Yeah, sure.
So that's the caution here, is to make sure we're getting an area predetermined.
Yeah. So the prep doesn't change based on your rebar cover depth. The prep doesn't change around your PT ducts. So I would make a point to do this test somewhere where you have more cover, and you get the same verification of the overlay, right? You get the verification of the prep without the risk of sparks, essentially.
Yeah, no, that's what I'm saying. So therefore, we need to identify that area, survey it, whatever, so we can get back in that same spot afterwards. Okay.
I can agree with that. Our material doesn't have a vote in that race, but as a person, I can say I'd love to not have the core drill hit steel of any kind.
Okay, we're on the same page.
We can see it.
Have you ever seen this break at the interface or?
No.
Okay.
I've seen it break super duper close to the interface because the substrate concrete was super weak. Usually that's what happens on a rehab job, especially northern jobs with a lot of salt contamination, and you get older, weaker concrete stuff, especially in the shoulders up north where the salt sits during the winter, and it ends up really kind of garbage concrete. I've seen it break really close to the bond interface, but we always pull some of the substrate with it. Just how it works.
What is the frequency? Is it by area? Is it by length? What do you do for, how often do you do this test?
That's I believe that's in the test method. It's 3 cores constitute a test, I believe. Specs and owners treat it differently. It's often that if your bridge doesn't change and if your substrate doesn't change, one set of 3 cores is considered sufficient, and then you move on with your life. And then you continue with the job and you trust that first test to be evidence for the rest of the job, provided that nothing else changes. The prep doesn't change, the substrate itself doesn't change, the installation operation doesn't change. It's still a valid test. We've got other jobs where we have bundled bridges together. So you're going to do, 8 bridges in a county somewhere, right? Well, if one bridge has a different substrate or it's on a new deck and one's on an old deck, it's totally reasonable to run a test on each of those, right? I don't see that for you guys. I basically see one test at the beginning of the job and then you move on with your lives.
So 6,000 square feet.
Moving on, surface preparation. You're going to shop blast it. They're going to shop blast it. I'm not looking for roughness. I'm not going to say just because they drove over it with the shop blaster that it's good. I'm going to say I want to see weak surface material removed. I want to see open pores in the cement of the concrete and some exposed aggregates. This means you can't go as fast as possible with the shop blaster. It also means the shop blaster tends to just kind of get it done. You see the prepped on the left looks nice and clean. I know it's kind of a small picture, but open pores looks good, right? On the right, that's dirty. That's not done yet. So this kind of shows you. Yours won't look like this because it's not that dirty, I don't think. But you get the idea. You should see it prepped. Open pores, some exposed aggregate. It doesn't have to be giant faces of coarse aggregate. It does have to be some of the aggregates, not just staring at cement paste. Also, in this picture, notice the crack. We are not worried about that. We are used to cracking. Because of the function of the methacrylate primer, nothing extra gets done with cracks. The primer addresses them. That's just nothing different in the prep. We just expect to drive over them and fill them with the methacrylate. Here's a picture of a shot blaster. Might get loud here. Ready, set, go. Notice that. Nice tidy operation. The machine vacuums up after itself. And notice how dirty that surface is, followed by how clean that surface is. That guy's moving at kind of a slow pace, but probably acceptable. And it's okay to go slow. It's not okay to go too fast. If they stop, it'll like dig a hole, but that kind of very rarely happens. But you see, that's what the operation looks like, and it's relatively obvious. Once you see a shot blaster doing appropriate prep and leaving it clean, you just go, okay, keep doing that for the rest of 140,000 square feet. Off you go. Tip, this is, and I'm going to have a few other points where I say this, this is me imparting my philosophy toward inspection on you guys and kind of highlighting something that to me is the thing that leads to more fights on projects between contractors, installers, and inspectors, is not saying things at the right time. Watch while they're doing it. I see all too often somebody goes, okay, they're prepping, I'll be over there. And then they come back when they're done with it and the paver is warm and the mixer truck's backing up to it and they're going to start priming. And they say, oh, I see a dirty spot here. You missed this, or it doesn't look like your shot blaster was even working over here. Watch them, and then it's a fight because they go, hey, we've been doing this for a day. You didn't say it then. So just, it's kind of an overall advice, but I relate it to prep in this case. Be there when they're doing it. And if you see something, say something. Don't wait until the shot blaster's on the trailer. And maybe you guys, you know, that's to me, that's just kind of doing a good job. I look at inspection as a partner on the job, not adversary. And I think this is a good way to be a partner, watching it as it goes. And then you can be helpful and go, hey, it looked really clean there. You're still doing the same thing. Nothing changed, but it's not clean anymore. And maybe a filter gummed up or something happened with their shot blaster. Then you're being helpful and pointing out the issue. I'll say the same thing again in a little bit for different topics. Now, blow it off after shot blasting. Shot blasting has a vacuum unit on it. It cleans up after itself, does a pretty nice job of that. Still needs to be blown off with a compressor. I don't know what happened in the last maybe 10 years in this industry, but I see leaf blowers. That's not it, okay? If you want to blow it off with a leaf blower first, because you want to gently move some of the dust, it still has to be done with a compressor. We've seen jobs where somebody used a leaf blower, even with a big backpack ones. They go, oh no, this is blowing it off. It's good. And we've actually kind of bet contractors before and said, okay, get a compressor. I'll blow it off with a compressor. And if no dust happens after your leaf blower, we're going to let it fly, you know? Well, of course, more dust came up. So I don't know why leaf blowers became popular recently that they have. This is also not acceptable. I literally took this video. Okay, that's not blowing it off either. To that guy, he considered that to be cleaning it. Just a little kind of a joke there, but I literally took that video and he literally did that with a straight face. Primer, the next step after prep. You can see these bullets for yourself. Notice, this primer is a relatively high-tech chemical. It's a very beneficial item. However, notice there's nothing high-tech here. We're mixing it in drills, we're dumping it out, and we're spreading it with brooms. Florida specifies methacrylate sealer for jobs. This looks a lot like that. Only after you've spread out the methacrylate on the surface, instead of throwing sand at it for friction, you are putting an overlay on top of it. And there's some different chemistry to it when it's a primer. Yes, sir.
Merit, I'm sorry to bother you again, and
Okay.
definitely apologize for interjecting. Why aren't we supposed to use actually hydro demo? Usually for latex modified, we get that application. What prevents us not to actually have that application
You
for
could.
the PPC?
You can. So we want a dry surface for this. So after hydro demolition, it just takes some time to make it dry, but we have certainly paved over hydro demolished surfaces, and that's okay. The reason latex does it is not because it's needed for the removal, but it's needed for mechanical interlock. So latex does not get true or not achieve true composite action with its substrate. What it achieves is mechanical interlock, which gives you a similar result to composite action and functionally kind of the same. This overlay, because that primer saturates into the substrate and then reacts with the overlay, and you'll see in a second here pictures of the primer going down and soaking in, we don't need it. So latex needs hydro to make a roughened surface so that they can get mechanical interlock. And when latex is placed over smooth surfaces, it often has a very short service life. So this overlay does not require it. It can have it, and we have done it, but it's not necessary. Does that
Thank you
address your
very much.
question?
Appreciate
No
the
problem. And by the way,
information.
don't listen, stop apologizing for interjecting. I'd rather you ask a question than walk away with a concern. Okay, so interject all you want. You're not going to screw me up.
Thank you. We receive a great education. Thank you.
Trying. Thank you. All right, so notice here, nothing fancy on these bullets about the primer placement. Here it is being mixed. Again, there's not a whole lot of high-tech anything. These are just people dumping easily measured chemical into a bucket of primer, mixing it with a drill mixer. I didn't show that, but it's just a drill mixer. You mix it, dump it out of the bucket, and then you spread it with brooms. Apply it to all surfaces to receive the PPC. What this means is that includes vertical, okay? That's it. I mean, this isn't rocket science here. This is just everywhere you're going to put the PPC, put the primer. The polyester resin in the overlay sticks to everything with or without primer, but the primer is like the belt and suspenders to the adhesion, right? So it's very helpful. Make sure you want to watch the vertical edges and make sure it gets everywhere. Make sure they don't miss anything. They're pretty used to that. I mean, these guys, the installers that you have, they do this. It's not like the only thing that they do, but they do a lot of this. So they're pretty used to it. But again, to be helpers, watch, and if they miss a spot, go, hey, you missed a spot, and then you're a helper. Here it is also, this is after it's dumped out of the buckets, just pushing with push brooms, nothing too hard, right? Watch for full coverage, put it down. Now, after that, by spec, by our rules, and by what everybody's used to, the primer should be in place 15 minutes before you put the overlay on it, and a maximum of 2 hours. There's headroom on both ends, okay? So for this, the 15 minutes, there's no cure. There's no, it's not like it gets tacky. This isn't tack coat or anything like that. What we're waiting for with that 15 minutes is saturation. So we're giving the primer time to saturate into the substrate. We are also, the 15 minutes, and this is the more important side of the 15 minutes, it gives you a chance to see it after it's down and see if it saturates in and essentially disappears. This is more common on patches and stuff on decks, which I don't think you're going to see. Your substrate's pretty consistent, so I doubt you're going to see this. If they put enough down, it should look consistent. But if it soaks in and essentially looks dry, you reapply at that 15 minutes. It's something that you're watching for, that it gives it a chance, because you want to prime it to refusal, and you want to give it the chance to soak in. And then if you need to reapply, you do, and you put more down. I don't think that's too hard to understand. It's really, really easy to look for. But that 15 minutes gives you that. It's not waiting for a cure. You're not waiting for it to tack up or anything like that. At the 2 hour point on the other side, this is important. If they don't get it covered within 2 hours, our primer is formulated to stay open and reactive much, much, much longer. It's not like at an hour and 50 minutes, you're standing there going, you're done. It's okay. If it looks dry, if it looks like it's soaked in, you can reapply primer over the primer. That's okay. Ideally, they plan their operation so the primer doesn't get too far ahead. Usually the 2 hour thing happens if there's a breakdown And it's not a reason to freak out. It's not a reason to just shut down for the day and come back. If you need to, you can reapply primer over it if that makes you more comfortable, or if you see any reason that it's needed, like it looks, set up or anything. The primer will gel and get hard if it's left in puddles. But it really, that's okay, but it won't end up dry. You'll feel it with your finger and it feels reactive. I'm not kidding at all when I say 6-8 hours after placement, it's still fine. It's still reactive. Let's not get to that point though. That's a point where you probably should definitely reapply or clean or wonder what's going on with your operation. But if they go over 2 hours, it's not the end of the world. Here it is being placed. Yes, sir.
Ambient temperature have anything to do with that? If it's hot, then, it seems like.
We are paying all of our attention to the surface temperature. That's the one thing that we really, and we're just, when we talk about temperatures within our company and talking to our key installers like these guys, when we talk about temperature, we don't even specify, and I mean surface temperature, we just mean it. That's it. But is the surface affected by ambient temperatures? Is the surface affected by sun or wind? Absolutely. So, but the temperature we're talking about is surface. If the
I guess
surface,
my question is regarding setting up of the primer. If it's hot outside, we expect it to get a little bit set up quicker.
I don't include details on this in these presentations because I don't want inspectors to feel like they need to be responsible for the levels that the guys are mixing it to. That's Truesdale's job to get that right, but they're going to mix it to the temperature. Basically, on your job, they're just going to mix it at the same way the whole time because I don't think it's going to be cold enough to need accelerator. So it's just kind of a straightforward mix because you're in South Florida. If you got into the cold, we would add an accelerator to the primer, and then that would be affected by it, by temperature. If it's hot out, it makes the primer go a little faster, but we have a huge broad range within their mixing conditions, so you should not see a whole lot of difference with that. Okay. Here he is putting it down. This guy's using a roller. Notice the other people were using a broom. I'm open. I like brooms better than rollers. A lot of the installers like rollers better. I don't care. I don't get in their way.
Pardon me, any precaution for evaporation?
No.
Excellent.
There's no
Thanks.
water. There's no water in it, so it's not evaporating. It's a chemical reaction.
Excellent.
Yeah. No, and you know what that relates to, I'm hearing a trend here. Latex is much harder to do. You're standing there using that whirlybird for the thing for the humidity and all that. I mean, I've been around it. It's a little more sensitive to these things. Ours are just chemicals with no water, so we're driving the reaction to deal with temperatures, but that's about it. We're not worried about, there's no drying, it's curing, and it's a chemical reaction, not a drying. So no, that's not a concern. Another tip, look at this. Same tip as I said with the prep, but be around the primer. And if the guy misses a spot and the primer truck is 100 feet away and you tell him that he missed a spot, he's got to walk with a bucket for that. He's not going to be he's going to get grumpy. If you see them missing a spot where they are, you just say something and they magically fix it. So again, it's a way to be a partner and a helper as opposed to making it adversarial. You're not worried about wood forming, I don't think. I include it here because I pulled from a canned presentation, but you could see this if there was a shoulder or a potentially or an approach that they missed or something. I doubt you're going to see any wood forms. You're going to see slip form pavers. Grade is established by the sliding grade beam, just like you're used to on an asphalt paver. I'll show you pictures. Visual checks of how the grade is established during placement. I mean, if it looks like it's 5 inches thick, then it's probably 5 inches thick. You can check it by sticking a nail in it and check your thickness. You're also able to use straight edge verification for deviation from a straight line. This should sound a lot like concrete. Your knowledge from concrete placement is applicable. Trust yourselves. Ask us if it is applicable. Feel free to discuss, but the truth is grade is grade. These guys are using automation. They're using automation hydraulic controlled automation on the paver. It's not that different than what you'd have on an asphalt paver or a concrete white topping machine or something like that. On to the mixing. Ask questions before you get started. You're not going to see any mortar mixers out here. I'll show a picture of it just because, again, I used a canned presentation, and just in case, if there's any joint work or something and the trucks are gone, it's a fine way to mix it. The material doesn't care, but you're going to see volumetric mixer trucks, and this is not Truesdale's truck. This company, the guy was a super OCD neat freak, so I use his pictures because his equipment's pretty. Most of the equipment is not this clean and pretty. It looks like construction equipment. Mortar mixer. Again, if something came around to this, if you had to do a repair later in the job or something, later on after Truesdale's gone and their mixer trucks are gone, if the team on site has to mix something, we can get you material in 50-pound bags that you can mix in mortar mixers on site to do a small thing. So I show it just so you can be prepared and know that that's a totally acceptable way to mix it, and the material does not care. And back to the mixer truck, this is what it looks like. The mixer truck backs up to the paver and dumps it right into the hopper, goes into a transverse auger box on the front, and the paver puts it down. Different angle. Resin content in the mix, not that different than cement content. You've got water content, stuff like that. It's different, but it's the same philosophy, and it's a similar math. The way it's calculated to get to the specified and kind of perfect range of 12 plus or minus 1%, it's not of the total, it's not of the whole, it is of the aggregates. So basically, your amount of resin that you need is the amount of aggregates going in times 0.12. Okay, that's how it's calculated. Again, it's not of the whole with the resin in there, it's just of the aggregates. What you're really looking for here is basically a good finish. And I know that sounds like kind of simplistic. I'm going to show you some pictures. It's way easier to see than you might be thinking. It's pretty easy to get it right, and it's pretty easy to see. And once you see the start of the pour and the continuation of the pour, you'll know what I mean by it. Low from 12 is common and very acceptable. For the thickness of overlay that you've got here, I'm gonna say probably 11.8-ish is what you're going to see happening a lot, just somewhere shy of 12. I doubt you'll see under 11.5, and I doubt you'll see anything over 12. Just from my experience. So that's kind of just what you're going to get. It'll be very close to 12, but if it goes below 11, but it looked good, then it might be a calibration issue. You could look to that. It's almost guaranteed to be 11.5 to 11.8, something like that. Too high can lead to cracking. So too low and still finished and looking good, and you can see what you see here. Look in the far end there. He's still finishing it. It looks loose, right? But it also just looks like it needs to be finished. Closer to the corner where the finisher is, look at how that's just flat, just smooth. It looks finished. That's good. This is at the drier end of acceptable, and I did that on purpose. Drier than this, he probably wouldn't be able to finish it in that area closer to him, but he got it done. Over here, that's also so this acceptable, okay? This also acceptable, but we're on the higher end of it. Any less than this, probably not good. Any more than this, probably not good, okay? But this is also acceptable. You can see the difference. You can see the bleed resin on the surface. That's what we're looking for resin content. Personally, me being out there, this is all I'm looking at. I watch their trucks. I sometimes calculate it. They've got a readout on the truck. I do the quick math on that and just do the resin amount divided by the aggregate amount. I check it, but I'm really trusting. We jokingly within our company say we have calibrated eyes and calibrated boots. And we know how to see what's right. You're going to know how to see what's right pretty quick. Little hard to see, but that blue pen is pointing at a crack. Also, look at how glossy it is. And look at how it's dry in some spots and glossy in others. They got enough top sand on it. That's what you're seeing in the dry. It's kind of a blotchy top sand job. This isn't like a common look, but you know, we grab pictures where we can. Notice how glossy it is. It's too resin rich, and that's what led to that crack. So the reason that it cracked is it was too much resin. It probably looked very resin rich behind the paver and where the finishers were, and they threw enough top sand on it to make it okay. That's okay in some areas. Like when they start, they're always a little resin rich at the beginning of the pour. You'll get used to that in the job. But you don't want to continue with too much resin forever, or it can lead to cracking, and this picture shows that. Finishing. Finishing is finishing. All right, don't let anybody tell you that this material is a little bit unique and it feels different than concrete, but it still just needs to be finished. Good finishers do what they do, and they can, if you're a good finisher on concrete, you'll be a good finisher on this. Slight difference is it's easier. The aggregates are all rounded, and since polyester resin flows a little bit better than cement paste, it's a little easier to do. But what you're looking for is very similar. You finish concrete to a nice creamy surface. We're trying to get a little bit less on the surface than that of the resin. We just want it smooth, flat, and shiny. That's all we're looking for. After that, you broadcast this top sand that we sell as part of the system. You're going to broadcast that on the surface. You want that to be even, not zebra stripes, not blotchy. That's a potential inspection item. They may not like at that point being told what to do because they're pretty used to throwing top sand, but feel free to. If it's all streaky, tell them, say, this is too streaky. It should be even, and you deserve to get an even surface. Here they are finishing. This is behind a screed, but the point of this picture is to really show you, you won't see a screed on your job, I don't think. But it goes to show you that they're handling it a lot like regular concrete. Notice what they're using behind the screed. Just a hand float. Behind that's a small Fresno. Stuff you recognize. Here it is behind the paver. You always finish the edges, and they will work that seam between, they're sitting on one, the guys in the foreground here, they're sitting on one PPC pass, and they've got the new stuff in the distance there in the far side. They're just finishing that seam, and when you need and work that seam together, it functionally disappears. And so that's what those guys are doing. The guy in the far end, he's doing nothing because all he's doing is beveling the edge, which I'll show you some better pictures of in a minute. This is a patch, but it shows you the finish. Notice you see the coarse aggregate. You still see the matrix of the material, but it's smooth, flat, and shiny. And here she is throwing top sand. It's a careful throw. It's only thrown by hand. I've seen lots and lots of people try and use blowers and seed spreaders. I haven't seen one work yet. A few times a year, somebody thinks they're crafty and they're the first person to think of that, and they try it and it ends up real streaky and ugly. I just have yet to see something that works better than a human hand to broadcast it evenly. It's going to get loud for a second. That's it. Okay, he's finishing it. Notice it's not a strange technique. It's not foreign to anybody. He's finishing it. That guy's just a finisher being a finisher. Edge treatment. I don't think you're going to see any wood forms in this job. If you do, you usually wax the wood, just tack it into the concrete, place within it. And then when you strip it, you want to make sure you remove the wax. We're going to watch for any needed prep at that point. But again, I don't think you're going to see any wood forms. What you are going to see is slip form paved. We're going to work that edge to a non-vertical. And I believe your spec has an adjustment in it that we discussed. It's not phrased as a taper. We're calling it a bevel, and that should be clear. Anything non-vertical is good. So it can be a 45. It can be a 4-on-1 taper. I'll show you a couple pictures. Next, if that gets dirty, contaminated in any way, abrasive blast it, just the same as you do the rest of the surface. It's really easy to do because all they have to do is not stay away from it when they're prepping the adjacent surface. Pretty easy.
Once you finish it, how long before you can walk? I mean, if the guys are finishing and
Mhm.
there is one area that they need to reach, can
Mhm.
they walk over and then finish
No.
it? Well,
But you don't want to, well, if it needs to be finished, then it probably can't be walked on. Just to phrase it that way, you'll need a work bridge to get access to things or handles on a Fresno kind of a thing. I'm just going to say you can walk on it when you can drive on it, and that's at 2 hours. The truth is it's strong enough to be walked on much earlier, but I try and stay off of it, even though it can hold a person, because I don't like to open, it's every single job. When it's walkable and I cut across it, it opens, I know when it's good, it opens the floodgates and all of a sudden everybody's walking everywhere and they step in a wet spot. And so I just say stay off of it for the 2 hours. Truth is, sometime between an hour and an hour and a half, it's fine to walk on and it won't damage it. But if you've got to walk to a finished area, you probably shouldn't be walking on it, because if you still have to finish it, that means it's not hard enough to walk on. With that vertical edge, or the edge of the seam that's no longer vertical, I should say, you tool it, and then you prep it if needed after cure. If it stays clean and they immediately place against it, you don't have to prep that. You do have to prime it. You prime everything that the PPC goes against, including previously placed PPC. Again, easy to do. Here's one, they kind of squatted their float into it and then drew it out at kind of a curved taper there. That's fine. Here's one where they just tooled it to a 45, more of like a bevel. That's acceptable. And then here's a better picture of the bevel. Nothing too hard to do. It's pretty easy to get it right. Potential deficiencies. Ugly, right? Everybody knows this isn't right. It's not rocket science. The fixes, though, much like regular concrete or even asphalt, when you cast fresh stuff across a kind of a segregated or unfinished area of concrete, or even can see it with asphalt. When it's fresh and before it sets, that's the way to do it. You just take a fresh scoop from in front, coming out of the mixer truck, sprinkle it on, finish it in, and eliminate these. If you find this after it sets up, which this picture is actually taken after it's set, prep it, which can be sandblasting or shot blasting. I like sandblasting because it's just, a little tidier operation. I assume we would see this in a small area. Prep it, prime it, fill it with sand mix PPC. So you mix kind of a sand catalyzed resin slurry, work that in, and then top sand it. This is a middle ground, okay? This isn't as bad, right? Again, the fix is if you catch this, well, it's still unset, just a little scatter of fresh PPC, finish it in, and then you've got the surface to top sand. After it sets, you can seal it with methacrylate and sand. You could do methacrylate and a little bit of resin and some top sand if you had to. The point to these is it's all fixable, but it's best fixed if you catch it while it's wet still. That's the time to do it. It's way easier. It's less work, no prep, none of that. No discussion of, well, does this need resin? Does this need a sand mix? That kind of thing. Last one, this is borderline. This is kind of a judgment call. Personally, I would kind of leave this. It's not going to deteriorate more from what it is. The only fix on it would be a little bit of sealer, and I would use a methacrylate sealer for this and sand, or you could leave it. This last one's kind of a judgment call, but it gives you a bit of a hierarchy of what the issues with finishing could be. Grade control. You're going to match existing grade on previous passes because they should be flat and smooth and ride great. The grade averaging beam, again, same as an asphalt paver, very typical equipment. Grade automation, hydraulic grade adjustment, things that you're used to if you've seen asphalt paving or concrete pavers for either concrete pavement or white topping on pavement, kind of the same thing. Here's a picture of it. Notice in the foreground, very foreground, it's precast, but then the PPC pass in its foreground, they are just dragging the pan of that paver and matching the existing grade because that previous one was placed so flat and smooth. And in the far end, you can kind of see it in the tail of the paver behind it, a grade beam. And now you can see the grade beam in the foreground of the paver here. This paver is coming towards us. They're running that grade averaging beam, and the automation is running on that. So should all look pretty familiar to anybody who's been around even other items. But these are just how it happens. After the fact, okay, you've got grade and ride issues. If you've got high spots that need to be shaved down, I say diamond grinding, but the fact is you can use a stripe eradicator, stripe grinder, that kind of thing, just to trim down a high spot if you need. If it's small, big areas, diamond grinding is just kind of the fix. We love to avoid it, but it happens. Low spots, prep the surface, shot blast or sandblast, fill it in with resin or resin and sand mix. Poor ride overall, bumps up and down, that kind of thing, fix it with diamond grinding. So, I feel very comfortable saying these things because it's not that different than any other concrete item. And since I live in Florida, I know a lot of bridges are diamond ground. I know Florida's comfortable with it. FDOT's comfortable with it.
So
great.
we're expecting to see another profilograph after this just to determine these kind of things. Is
Yeah,
that, are you guys on board with that?
I don't care. You got to talk to Truesdale. The material doesn't care.
No, I'm asking the contractor. I'm asking Tyler.
Yes, we plan on doing that.
Yes. Very good. Thank you.
This is just kind of a unique picture of something. And again, I keep using that theme of say something when you see it. This is entirely fixable by diamond grinding, right? But how about you see 5 feet of this behind the paver because you stand back and you look and you say something and they go, oh man, something's jammed in the who knows what or whatever they say, and get something done. You say something about this at the end of the bridge when it's miles of it done, then you're diamond grinding the entire thing. Like say something early and, just be a helper with that. But, kind of a unique picture there. This is a big inspection item, and I don't get a lot of people watching it as closely as I wish they would, because again, it's a place to help. So checking the gel time, you just push on it with your finger and you feel that the resin has gone from a liquid state to a gel and solid, and it happens kind of immediately. It's really easy to check for, and our people on site will be able to coach you through this and show you, okay, this is liquid, this is doing nothing, this is here, it's kind of gelled, this is when you know the reaction's happening, go 10 feet up, this is hard. And so we'll be able to show you all of that. The spec range there is 30 to 90 minutes, I think. I guess I should have looked back at your spec. It might be 20 to 90. The point is, with that, shorter is okay. It's just going to get hard faster. It's still going to reach the right properties. It's not going to change the final properties. The risk with a shorter gel time is not getting it finished or not getting it sanded. But the risk is not achieving properties. If you go lightning fast, there's a point where you can crack from going too fast, but that's kind of not going to happen behind a paver. That's more for patching where you do, I got to put traffic on this in 30 minutes and we go nuclear with the levels. You're not going to see that here. Longer gel is a problem. So here's a picture of checking the gel. Kind of what I'm illustrating here is that it's also not very high tech. There's no equipment. There's no test method. We explain to you how to do it, and you crouch down next to the overlay and poke it with your finger. Before we get to that, the long gel is more of a problem, and I'll get to that in a minute. Here's the tip on gel time. Check it as they go. This is the way to do it. You're walking along behind the paver, and it seems to be gelling. I'm just going to throw something out. Let's say 50 feet behind the paver. It's gelling about 50 feet behind the paver consistently. And as the paver moves at its pace, the gel moves at the same pace. Things are good, right? Nothing changed. Now, if it does change, you ask the contractor and say, hey, the gel changed. They might say, yeah, we're expecting it to get hotter out, so we reduce the levels. We expect a longer gel now. It'll catch up later. Great. There's an answer. Happens faster. They go, yeah, it's late in the day. It's going to get cold tonight. And so we ramped it up a little bit to deal with that. Great. That's their job. They will do that. You don't have to tell them to. But at least there's an answer there. If you say, hey, it's been gelled 50 feet behind the paver all day long, and now it's like 150 feet back, it's still not there. What's going on? They might look at you with a shocked face and go, I don't know. I didn't change anything. What's going on? Now they can look at their operation and say, you know, is a pump malfunctioning or something like that? Now you've been a helper. Okay. But it's a good thing to watch. What you're watching for outside of just being a helper to their operation is if it gets to be too long, you're going to have to take it out. Okay. And basically, let's see, where do I say that? I don't know if I say it here. Yeah, we're going to get to that in a little bit. So strength gain first, along with the gel time. The next thing you're watching for in strength gain is Schmidt-Hammer readings. Your spec, it doesn't say, I wrote 25 here because I'm looking at Schmidt-Hammer readings. We're not crushing cylinders and cubes to correlate on this job with Schmidt-Hammer readings. It's a waste of time. You just want to see what the hammer says equals 3,000. So your spec says 3,000 on the Schmidt-Hammer. It's got a little gauge on the side of the Schmidt-Hammer that tells you what Schmidt-Hammer reading equals that. It's around 30 on the Schmidt-Hammer, 27. I say 25 minimum is like what you've got to see here. But the hammer, depending on which one they use, will tell you what that is. And it's probably going to be 27 or something like that. Your spec says you must have 3,000 on a Schmidt-Hammer at 4 hours for acceptance. Okay. We can get further into that at another time for what you do if you don't have it, but that's what the spec says, and I back it up. It also says if you are going to return traffic before 4 hours, you have 3,000 on a Schmidt-Hammer for traffic return. Okay, so you still need 3,000 on a Schmidt-Hammer at traffic return or 4 hours, whichever occurs first. Okay. Here's a picture of running a Schmidt-Hammer. Okay. It's a tool. Now we're into something a little bit more high tech than just poking with fingers and stuff. But it's still not too high tech from a distance here. You just kind of walk around and check it with a Schmidt-Hammer. I hope you guys have one. If you don't have one on the job, if you want to buy one, I can help recommend the brands that we know and love. Just ask me. The advantage of from your standpoint, if you buy a new Schmidt-Hammer, they sell for maybe $500 or $600, I think. And they come calibrated with a certificate, which is kind of a nice perk. Then you know your hammer's good. Potential defects, and I'm going to cover a whole bunch of them.
I have a
Yes, sir.
question.
Yes.
Not heavy traffic, but traffic next to a just finished.
I love
section.
that question. I love that question.
All your
I love your
placement, too.
latex experience. I keep telling you that you're right to trust yourself with your latex experience. I keep telling you that you're wrong. I'm sorry for that. Traffic is fine. So there's a difference. Cementitious concrete has to depend on crystal structures built within its matrix to develop the strength. Vibration and bridge deflection around curing cementitious concrete affects the curing, affects the strengths, leads to cracking, leads to a lot of problems. This, not the case. It is a polymer resin building polymer chains, and it all happens despite vibration. You will not affect this material with vibration from adjacent traffic. It has no effect on it, except, well, it's still not set. If it really shakes around a lot, it could, in theory, affect the ride, like you're bouncing the paver or something. It really kind of doesn't happen. I don't expect that to be an issue. So great question. Love it. It's a sales pitch of ours. I didn't include in this because I didn't consider it an inspection item, but it is certainly an important fact. Adjacent traffic does not affect this. We are not building crystal structures that can be interrupted by vibration. We're building polymer chains, which are immune to it. Moving on. Potential defects. I'm going to cover a range of defects. Not a lot of them. There's not a whole lot that goes wrong typically, and it's relatively obvious. Cracks in the overlay. This could be from being resin rich, it could be from slow cure, it could be from any number of things. It could be from the substrate. We'd look at it and help you figure out what it is. Doesn't matter. The point is you fill it with a methacrylate primer. The same primer is what they have on the job. Catalyze it, drizzle it into the crack, fills the crack, fixes it, makes it fine, makes it permanent. Very, very easy fix. You have compatible repair materials on site because you're using the primer. Very easy. Other potential defects, it doesn't set up. So this is, you're checking the gel time. It's been gelling fine. It's been going fine. All of a sudden, it just never gets hard. And you hit a point where you're like, hey, it's been 2 hours. It's not hard. Why would that be? Either little or no catalyst, maybe a plugged pump, misadjustment, something like that. Not likely, but that is a potential cause that we would look at. And the other is moisture in the mix. If your aggregates were put in the truck, got rained on, they were saturated wet, put down, it won't get hard. Okay, that's what happens. It's not that moisture makes you lack properties or affects them in a finite manner. It's that moisture in the mix makes you just not get hard at all. Total lack of strength. We can also see it. So again, with our calibrated eyes, if this happens, it'll become very obvious to your people on site. Once we explain to them, yep, that's what happened, you'll see the difference. It kind of looks like creamy coffee, basically. It goes from kind of a certain look to a creamier, light brown, pale, creamy coffee look. And we can see that and we go, oh, that's moisture. That's it, just moisture. What do? Back to the gel time now. I feel like I'm bouncing around a little bit. I wanted to include this in the defects. So you're checking gel time and you say it's been gelling at 30 minutes or give or take 30 minutes all along and life is good and the operation's going great. All of a sudden, it's not gelled an hour after placement. What do? You just make mention of it. You keep an eye on it. That's not itself a problem. It's not going to lack properties. It can still get there. It can still cure just fine at an hour, okay? Hour and a half, it's not gelled. You're into a judgment call here. You could leave it and say, hey, it's going to be much harder to remove if it gets hard, but not that hard. But at an hour and a half, maybe it gels a minute later and you go, okay, we'll leave it. We'll check with the Schmidt hammer at 4 hours. We'll allow this. At 2 hours, if it's not gelled, or at an hour and a half, you can go, hey, it appears it's one isolated area that happened.
What you need?
Say, take it up. Yes, sir.
I will be there.
What's that? Was there a question?
Yes, Meredith, I got a question for you on the subject of the aggregate gradation.
Mm-hmm.
Your specification indicates the hardness should be minimum 7.
Mm-hmm.
And at the same time, unfortunately, in South Florida, we don't have a natural sand, as you have indicated.
That's why we do not get aggregates from South Florida.
Okay, so that's all I wanted to know. Thank you.
Yeah.
Thank you very much.
No problem. Yeah, this is all sold by us as a complete system. There is no source for these aggregates. We actually buy from multiple sources and then we run it through our blending operation. And we have basically 4 of those around the country. We're always trying to set more up, but that comes from more business. And so we truck it in flatbed trucks with super sacks on it. And there is no single mining operation or quarry that can make this gradation, even just the sand alone, but it's nearly impossible to get the sand and the stone, the pea stone from one location. So we manufacture it. We buy from multiple locations, run it through our blending, put it into super sacks. It's also why we don't ship it in bulk, like tankers, it comes in super sacks to maintain the gradation through it. So basically it's 4,000 pounds of all, if you sieved it, in theory, it'd be all come out perfect, instead of pneumatic driven tankers or something. Is there another question?
Yes, I got another question. Is actually the pay item would be on a volume basis or the weight basis?
Wait, I'm getting to that.
Oh, sorry about that.
No problem. In fairness, I told you to interrupt and ask questions. You're doing exactly what I said. You're not going to hurt my feelings. So back to the gel time. Judgment call at an hour and a half, not much of a judgment call at 2 hours. If you don't have a gel at 2 hours, you got nothing. It's way easier to take it out with shovels, before it sets than it is to wait and have it set up a couple hours later and be sort of hard, but like nobody trusts the properties. You get to 2 hours, take it out. Pay quantity. Hey, I think we talked about this. You are going to get a mixer truck ticket, and I'll show you a picture of one that's not a, I don't think it's a Truesdale one, but whatever. So you're going to get truck tickets, printed tickets that they're going to give you. It's per spec, per their equipment, and all that. It will give you the weight of the resin and the weight of the aggregates placed. You should be paying them by two. Oh, I don't know. I can't tell you what to do. I can say the normal way of paying, the standard way, is to pay two items. One is a volume item that is calculated by taking the weight of aggregates placed and the weight of resin placed, adding them together and dividing by 135, which is your unit weight in pounds per cubic feet, and paying that quantity, cubic feet. I don't care if you convert it to yards with 27 or what, but that's what you're doing. Then the area, obviously area, I don't feel the need to talk about how to calculate area, just do it. The reason for two I could get into, but basically it's like, you don't want to just pay volume, or if it goes a little bit thicker, you're paying for more finishing and prep, but you don't want to only pay area, because if it gets thicker, then they get screwed out of material costs. So the two pay item system is the most fair and common way to do it. Is that clear? Did I answer your question on the pay items? That seemed pretty easy.
Thank you very much. Yes.
Yeah, and the calibration on the truck is something earlier that relates over to this at the end of the job, right? That's part of the otherwise the calibration, I can do it by eye and say, yeah, your mix looks good. The other part of the calibration is to say, we're going to pay by it, so we want to know that your computer matches the actuals. Here's an example of a ticket. There's a lot of information, but right in the middle, you just see it's like, it says styrene, but that's actually the resin. It's part of the long name of it. So, you just take these, divide them out, you get a volume, off you go. I'm done. Questions?
I have a question, Mark, Scott.
Yes, sir.
So we have some inconsistencies in the height of our traffic railing. How are you going to maintain the proper? Now, in many cases, we poured a little high, so this is good. But where it is at the correct height, how are we working that in to make sure that we're maintaining traffic railing height?
Is it rail or precast or concrete?
It's concrete.
Yeah. So that would be a better question for the installer than me, but the material doesn't care. The material doesn't care about safety of rail height stuff. The material cares about friction for safety. So I'd speak more from that stance. I think you need to be clear with Truesdale, giving them grades and giving them grades and elevations at that point, and then you build up your cross slope from there to the middle and get what you get. One of the things is if you need to place it below or above a certain point, you're going to want to know that at the shoulder so that you plan your grades out to wherever the crown is or whatever high point you have, and build it through that way to that point and know it up front. I've been on jobs where we started out in the middle, started placing, ran cross slope all the way over, and just buried that little toe of the concrete barrier.
And you might have, so maybe that's more for Tyler then to respond. I didn't know, I understand that you're not the installer, but
Yeah,
Tyler, I
I
know
mean,
you guys shot grades out there, so.
Yeah, we're above 36 on the entire bridge, but it is close if we were to put the 1.25 inches right up next to the barrier wall. So we discussed this with Truesdale, and they're gonna run a string line across the shoulder, and then right next to the barrier wall, they can actually bush hammer it down to basically 0, and we will achieve the 36 inches that way. So they're gonna taper it down.
You stay on top of that while it's happening. So you can work it if you have to, That's
Yes,
something.
yes, of course. Yep. This
Who's
was,
doing QC for you, Tyler, on this? Who's doing your QC for this?
as far as from the CJV,
You see it?
I will be out there, inspecting it and ensuring that it's as per the plan, but, Truesdale will be doing all the rebound and the bond tests.
We anticipate getting you comments here in the next day or so from your TSP. We've received some, we're waiting on a little bit, little more, but, should be getting that. In terms of grades and profile, I basically understood the presentation of some of the questions I had that covered it. The rain issue is certainly a concern here, that the surface has to be dry, so, that based on when we're gonna start, this is gonna have an impact on your operation, I believe.
Yeah, we work, and Truesdale works in some pretty rainy places. As a company, we at QuickBond do a lot of work up in the Pacific Northwest. And that's a pretty challenging place to work. I would put Florida kind of on par with it, where things just don't dry out real easily.
Right.
You know, there's going to be some judgment calls to make in there. But I think, you know, we'll get through it because we always do. I know it's kind of a crappy answer, but
How do we determine a surface is dry enough, if you will, to start it up?
I have my own little test method. I believe it's in your spec, and I like it. You do something to dry the surface, like run a weed burner or a compressor, you know, something that would normally be used to dry the surface. And if it doesn't change the color, and if the surface looks dry, then it is dry. So we often rely on visual tests for that. If Florida is comfortable with a moisture meter, we can help you with that. But I've seen surfaces that like show 4% moisture in the concrete, and they're like, all right, we're good to go. And I'm like, it looks wet. No, I struggle to trust that. If it looks dry, and it looks dry in the cracks, and if you do something to dry it and that doesn't change the color as a verification, go with it.
Very good. Teddy?
Yes, I think you mentioned that after the short blaster that you're going to blow off the surface. Is this going to create a dust in such a way that we may need to do some confinement or not?
No confinement, no containment. You are worried about adjacent traffic somewhere, if the wind is blowing right at them. But the nice part about this, and just pay attention to it. I can't say that it's a non-issue. I can say it's a very, very minor issue. The reason is the shot blaster has a vacuum unit on it, and it sucks up and contains its own dust. Then they drive off site and dump it out. That answers for the bulk of what's removed. What's left behind after the shot blaster is not a lot. If it were to become an issue, that's when I become a fan of leaf blowers, because they don't move a lot of the dust far and they don't make as much of a plume. So you can blow it off to the side and kind of sweep it and move it, and then with a leaf blower, and then hit it with a compressor just to move the final little bit. I rarely see that though. Truthfully, the shot blaster running properly, it really vacuums a lot of its own operation up. And so you're not left with enough to be a big issue.
Okay, thank you.
No problem.
Hi, I have a question. On the bridge, we have some patch that we did with epoxy grout. Would that be any issue to, or the PPC will bond to that surface area that we?
So you're asking the wrong question. The truth is the PPC will bond to that epoxy grout just as well as it bonds to everything else. The problem is epoxy grouts by nature have a very high coefficient of thermal expansion. And so they tend to break away at their own edges and not last. We've seen it on a lot of jobs. We just usually say just don't use epoxy grouts. They're not good for application on bridges. Between the movements of the bridge and their own thermal contraction, they usually end up breaking away at their edges, and that will reflect up through the PPC overlay, and you will see the exact shape of your grout pockets right up through the overlay. Option is to take it out and use PPC, which has about half the coefficient of thermal expansion as what those epoxy products do. But if they're there and they're doing great, just go over them and hope for the best. But just be aware that, especially if they've been there for a while, that helps a little bit. They've been through their thermal cycling. They've probably broken whatever they're going to break.
Okay. So
Got a lot of.
some of them are sizable. Not like I mean, I appreciate the response. It's not liking the issue we have is that we have.
Scott, you're not muted, by the way.
No, I know. I'm talking to you.
Oh.
I'm not liking the answer that we just heard about. Your question was a good question that whoever asked it on your end, and then the response is that it's not good for use with this.
It's not that it's not good with the use of this material at all. Let me rephrase that. We stick to it, and if it doesn't break away from the edges of its cavity, we'll stick to it forever, and it'll be fine, and you'll have non-issue. I find that those materials, whether there's an overlay on top of them or not, tend to shrink away over time through their coefficient of thermal expansion and break. If you were leaving this a bare deck with those grout pockets, they would break away from their edges eventually and get moisture in it. It's just what we see. The difference is with an overlay, it'll reflect up through it. Here's what I would do. If they're big, maybe consider taking them out. If they're not big, leave them in and just know that when they break up through the overlay and you call me and complain about cracks in the overlay and we look at it and we realize that's what it is, I'll say, okay, the fix is easy. And we'll fill it with some primer. If they're not big, then coefficient of thermal expansion is less of a problem, right? I mean, that's a function of length with how much motion you're going to have and how much thermal shrinkage. So that's okay. But I mean, we've seen happen on other jobs where they fill grout pockets, and the bigger ones, when they fill them with these epoxy grouts just, they're not as high performance as they claim. So regardless of an overlay going on top of it, they're going to do the same thing as I'm describing to you. It's not the overlay's fault.
Okay, but can we clear those areas? Can we put like a metraca light
Sure.
and put the PPC on top?
You prep it the same way, put the PPC on top. We're going to stick to it just fine. That's all you need to know. And if it shrinks away and breaks away and fails, that's the epoxy grout failing, not the overlay failing, but the overlay, it'll be indicated through the overlay.
Well, I'm thinking about Bridge 4 and that one repair that we're about to.
No, we have a big section.
No, I know we have it, but we're gonna go out and do it again on Bridge 4, and we're gonna use an epoxy on this large area. And maybe that's not the right approach, and it's something you guys need to think about, I guess.
Do it with the same PPC as the overlay, and you won't have that problem.
I'm hearing you, but that's just not what's been proposed and all we're considering at this point. But story, that's another topic, I guess. Yeah.
Hey, Scott, I don't think we proposed an epoxy grout. I think that's a repair concrete mortar that we proposed for that pour back. But the areas where we would have the E3 deep pour, the epoxy grout would be all of the cantilever tendon pour backs, the bars and the EJs, and then a couple of locations where we had the blockage in the duct, we opened up a channel. And we poured some of those back with E3, but those are isolated locations. So Merritt, as far as the size goes, most of these are 6 inches by 6 inches, very small square or circle. A couple of them may be 6 inches by 2 feet, and that's very few in between. So we are talking about a small surface area here.
Yeah, so we've seen grout pockets from like lifting lugs on precast panels and stuff that were filled, have problems, maybe, I don't know, a foot by a foot or something like that. I don't know. I mean, it's up to you guys. I probably would roll the dice on it and leave it, but just don't be shocked if it cracks reflectively when those shrink away. you know, and fill it with something or take it out if it's unsound. But I mean, I wouldn't go around tearing them all out if they're sound and good and they haven't broken away from their edges yet. I don't think personally, if I were in anybody's shoes here, I don't think I'd go around tearing them out. I would just be aware. You asked about it, and I gave the sorry, brutally honest answer. It's just what we've seen in the past with those epoxy grouts.
Okay. Good question. Appreciate the answer.
Sorry. I give you
No.
give you honesty. Sorry if it's not what you wanted to hear. I get it.
Hey, Mayor, I got a question on the safety side of things. So, talking about noxious gases, is that the only time we need to be concerned during the actual mixing operation, wearing respirators, or is there other times throughout this process that we need to be concerned about off-gassing and fumes?
Most of our projects, you will not see anybody wearing a respirator. If you want to, if the gas is, if the smell of the styrene, which is what it is in the resin, gives you a headache, you probably also get headaches from asphalt. This doesn't smell as much as that. We've had air monitoring on a lot of jobs, a lot. We're from California. This was developed in California. They do a ton of testing. They still do if it's near a dwelling or a commercial venue or something. They have air monitoring on individuals on the project, and it's usually well under 1/10 of the OSHA permissible exposure level for styrene. So it's just not a problem. The place I would say respirators are most important are, one, if you're handling neat resin, like you're the guy pumping resin from the tanker truck, which we're going to deliver the resin in, into the mixer trucks, and you're like neat resin flowing in a hose and you're holding the hose, often that guy wears a respirator and I back him up. The other is anywhere right at the mixer where you can have, before the resin is mixed with the aggregates, you've got silica sand in the air. So I know you asked about gases, but I'm going to bring it over to sand in the air also. I don't want to breathe that. I'm more concerned with that as a person than the smell of it. But if anybody wants to wear a respirator, the most important thing I'll say is you can't just throw on a respirator. You got to have the cartridges that cover organic vapors. Otherwise, you're basically wearing a dust mask for vapors. And that if somebody wants to wear a respirator or is required to, I get pretty prickly that they have the protection that they think they're getting, and that comes from the organic vapor cartridges. But I haven't worn a respirator in years. Many people around us haven't. But you'll see people in Truesdale's operation that do. Probably like the guy at the mixer truck for the sand, for that, and then the guy moving the resin by pump from tanker to into their trucks.
Okay, thank you.
And then officially, I'm supposed to say this, I defer to the SDS sheet. You should read the SDS sheet. All individuals should see the SDS sheet and follow what they see as important on the SDS sheet and protect themselves accordingly.
All right, thank you, Merritt. Does anybody else have any other questions? No, everybody's probably hungry, so.
Yeah, I got a meeting at noon. How am I doing?
All right, well,
really
I want to appreciate, send our regards here, appreciation that this was beneficial to our team. Tyler and CJV, thanks for putting it together. Merritt, if you get back with me on the job, I was just, some people are communicating with me from Pennsylvania that you might have some projects this weekend or next week that might be going on.
That's good. So what you want to do, watch your Pennsylvania jobs. The one, do you know where it is? What job it is?
He said, let's see. The Fern Hollow Bridge replacement.
No, don't go to that. That's a material that's a copycat to our material, and it is all failures. They have no successes yet. Don't go there. That's a contractor who has never done it before, inspectors that have never knowingly driven on it before, and a material that doesn't stick. Don't go.
Sounds like fun.
Yeah.
Then he said something in their District 11 in Pennsylvania. I don't know. Talk to Michael Sursley. That's what I got.
That's probably better. What you want, the contractor in Pennsylvania that actually does this is called JD Ekman. Make sure you go to one of their jobs. If you're talking to somebody in Pennsylvania, Fern Hollow is the one that collapsed a year or so ago. No, that's the first time that material is being installed in Pennsylvania, and just above the border in New York, it's falling apart. They've done probably 6 installations around the country, and almost all of them are falling apart within the first month. Don't go. And that contractor's never installed it before.
All right, well, I'll look to you to send me some
Yeah.
examples that are gonna be similar to ours, and I'll work with you
Yeah.
on that.
Yep, no problem.
Yeah,
I'll get back to you.
This is two with big ones. If you want, I can also get you in touch with JD Ekman directly. They're doing a few projects in parallel, probably in the next few weeks, next few days. So I'm sure they're not going to have an issue. They haven't had an issue before about people coming and seeing their jobs. So I can get you in touch with them as well.
I need that information so we can take that as information.
Okay.
We'll get that together for you.
Yeah, appreciate everybody's time. Thank you.
And but by the way, I hope this was helpful, but we're also still available. We're going to have people on site to answer questions and guide this. And we're available in the meantime if you have a question that comes up. At some point, we got to stop talking to you too much because it gets close to the installation, and that would be sidestepping the CJV and Truesdell. But, you know, I mean, if they're just general questions, shout out. We're here. We want it to go well. We want you to have confidence. Feel free.
Thank you.
Thank you, guys.
Okay. See you later.
Thank you, everyone.
Bye-bye.
Right, thank you.